so the last example I did, and one example type of like the interest is just, here's your rate, here's your compounding, here's your length of time, here's your principal, plug it in and chug. The other type might be where I have to actually kind of solve for something. So this one, I know that they want to earn $1,400 in interest in 2 years' time, and they're going to invest $20,000. They know the compounding, and the question is, what must the annual interest rate be? So they know, they know how much they have and how much they want to get. What they need to know is what interest rate they should be looking for, at least. If it's better, then obviously that's great, but it has to be at least, you know. All right, so with this, because I'm told that it's compounded semi-annually, that means I'm going to be using the long equation. So A, P, R, N, and T. All right, the principal is how much they invest, so they're investing $20,000. The rate, that's the thing that we don't know, right? What must the interest rate be? So this is the guy that's going to be the question mark. N is how many times per year it compounds. This says semi-annually, and semi-annual means twice per year. So that's a 2. And they want to earn their interest, in 2 years' time. So T is also 2. So I have to figure out what A is. Now remember, on the previous problem I said, well, once I plug in all this information, I get how much the account is worth. So that's the original plus the interest. That's A. So it's not that A is 1,400, but A is your original plus your interest, which in this case means A is 21,400. So that's what I'm going to solve. I'm going to have A, P, R, N, and T. Sorry, not R. So I'll be able to solve for R. So let's look at, here's my formula. Okay. A is 21,400. P is 20,000. 1 plus R I don't know. N is 2. Then 2 times 2. Okay, so because I'm looking for R, R is trapped inside of my exponent expression, right? So this is an exponent that I can calculate. This is going to be 4. So this we did basically back in the radical and even the quadratic section. If I would take a 4th root, I'd be able to get rid of that power. So in order to take a 4th root, the first thing I'm going to do is isolate the R as much as I can, which means divide both sides by 20,000. Okay, so 21,400 divided by 20,000 gives me 1.07, which, by the way, this tells me right here that it's roughly a 7% increase. From beginning to end was a 7% change. All right, R over 2 to the 4. So now I'm going to take a 4th root of each side. And usually if I take like if I take an even root, I need to do plus or minus. I obviously don't want a negative rate, so I'm only going to need the positive. Take a 4th root of this. All right, so here's what I have. Then 4th root and the 4th power simplify, giving me 1 plus R over 2. The 4th root of 1.07. I would just leave this as 4th root of 1.07 for now, and then worry about simplifying when you're in the calculator. So I need to subtract 1 that gets me fourth root of 1.07 minus 1, and then I'm going to need to multiply by 2 times 2. So that's going to be my rate. When I put this in a calculator, so for the fourth root, you can either use your nth root key. So on this one, it's the second on this key right here. On this yellow one, I know some of you guys do have one that looks like this yellow one. This is a TI 30XS. It's with, let's see, right here. It's with the power key. And it usually does go with the power key. It's usually the second. Okay. So I want the fourth root of 1.07. And by the way, look how exactly how I have it written. That's what I want to write in my calculator. All right. Minus 1. Make sure that you've exited that radical. So here's my cursor, and then one more time that gets me out from under the radical, because otherwise if I put minus 1, now it's inside of my radical. All right, so minus 1, then, oops, times 2. So that's 0.034. So as a percent, that's 3.41%. Now, let's go back and do what I would call a sanity check. I had mentioned here, this is this indicates that I needed a 7% increase over 2 years, which would be a 3.5% increase each year. But I've got this compounding semi-annually, so I don't need all of 3.5%. I need just a little bit less because of that compounding. So Angie needs to look for an account that gets her at least 3.41% interest every year.